Chapter 1 Review. Problems. 1.1. The scope and scale of physics. 14. Find the order of magnitude of the following physical quantities. A. The mass of Earth's atmosphere, 5.1, multiplied by 10 to the power of 18 kilogram. B. The mass of the Moon's atmosphere, 25,000 kilogram. C. The mass of Earth's hydrosphere, 1.4, multiplied by 10 to the power of 21 kilogram. D. The mass of Earth, 5.97, multiplied by 10 to the power of 24 kilogram. E. The mass of the Moon, 7.34, multiplied by 10 to the power of 22 kilogram. F. The Earth-Moon distance, semi-major axis, 3.84, multiplied by 10 to the power of 8 meter. G. The mean Earth-Sun distance, 1.5, multiplied by 10 to the power of 11 meter. H. The equatorial radius of Earth, 6.38, multiplied by 10 to the power of 6 meter. I. The mass of an electron, 9.11, multiplied by 10 to the power of negative 31 kilogram. J. The mass of a proton, 1.67, multiplied by 10 to the power of negative 27 kilogram. K. The mass of the Sun, 1.99, multiplied by 10 to the power of 30 kilogram. 15. Use the orders of magnitude you found in the previous problem to answer the following questions to within an order of magnitude. A. How many electrons would it take to equal the mass of a proton? B. How many Earths would it take to equal the mass of the Sun? C. How many Earth-Moon distances would it take to cover the distance from Earth to the Sun? D. How many Moon atmospheres would it take to equal the mass of Earth's atmosphere? E. How many moons would it take to equal the mass of Earth? F. How many protons would it take to equal the mass of the Sun? For the remaining questions, you need to use figure 1.4 to obtain the necessary orders of magnitude of lengths, masses, and times. 16. Roughly how many heartbeats are there in a lifetime? 17. A generation is about 1/3 of a lifetime. Approximately how many generations have passed since the year 0 AD? 18. Roughly how many times longer than the mean life of an extremely unstable atomic nucleus is the lifetime of a human? 19. Calculate the approximate number of atoms in a bacterium. Assume the average mass of an atom in the bacterium is 10 times the mass of a proton. 20. A. Calculate the number of cells in a hummingbird assuming the mass of an average cell is 10 times the mass of a bacterium. B. Making the same assumption, how many cells are there in a human? 21. Assuming one nerve impulse must end before another can begin, what is the maximum firing rate of a nerve in impulses per second? 22. About how many floating point operations can a supercomputer perform each year? 23. Roughly how many floating point operations can a supercomputer perform in a human lifetime? 1.2. Units and standards. 24. The following times are given using metric prefixes on the base SI unit of time, the second. Rewrite them in scientific notation without the prefix. For example, 47 teraseconds would be rewritten as 4.7, multiplied by 10 to the power of 13 second. A. 980 ps. B. 980 fs. C. 17 ns. D. 577 mus. 25. The following times are given in seconds. Use metric prefixes to rewrite them so the numerical value is greater than 1 but less than 1000. For example, 7.9 multiplied by 10 to the power of negative 2s could be written as either 7.9 cs or 79 ms. A. 9.57 multiplied by 10 to the power of 5s. B. 0.045s. C. 5.5 multiplied by 10 to the power of negative 7s. D. 3.16 multiplied by 10 to the power of 7s. 26. The following lengths are given using metric prefixes on the base SI unit of length, the meter. Rewrite them in scientific notation without the prefix. For example, 4.2 petameters would be rewritten as 4.2 multiplied by 10 to the power of 15 meter. A. 89 terameters. B. 89 petameters. C. 711 millimeters. D. 0.45 μm. 27. The following lengths are given in meters. Use metric prefixes to rewrite them so the numerical value is bigger than 1 but less than 1000. For example, 7.9 multiplied by 10 to the power of negative 2 meter could be written either as 7.9 centimeter or 79 millimeter. A. 7.59 multiplied by 10 to the power of 7 meter. B. 0.0074 meter. C. 8.8 multiplied by 10 to the power of negative 11 meter. D. 1.63 multiplied by 10 to the power of 13 meter. 28. The following masses are written using metric prefixes on the gram. Rewrite them in scientific notation in terms of the SI base unit of mass, the kilogram. For example, 40 mg would be written as 4 multiplied by 10 to the power of 4 kilogram. A. 23 mg. B. 320 tg. C. 42 ng. D. 7 gram. E. 9 pg. 29. The following masses are given in kilograms. Use metric prefixes on the gram to rewrite them so the numerical value is bigger than 1 but less than 1000. For example, 7 multiplied by 10 to the power of negative 4 kilograms could be written as 70 cg or 700 mg. A. 3.8 multiplied by 10 to the power of negative 5 kilogram. B. 2.3 multiplied by 10 to the power of 17 kilogram. C. 2.4 multiplied by 10 to the power of negative 11 kilogram. D. 8 multiplied by 10 to the power of 15 kilogram. E. 4.2 multiplied by 10 to the power of negative 3 kilogram. 1.3. Unit conversion. 30. The volume of Earth is on the order of 10 to the power of 21 meter cubed. A. What is this in cubic kilometers, kilometer cubed? B. What is it in cubic miles, miles cubed? C. What is it in cubic centimeters, centimeter cubed? 31. The speed limit on some interstate highways is roughly 100 km per hour. A. What is this in meters per second? B. How many miles per hour is this? 32. A car is traveling at a speed of 33 meters per second. A. What is its speed in kilometers per hour? B. Is it exceeding the 90 km per hour speed limit? 33. In SI units, speeds are measured in meters per second, meter per second. But, depending on where you live, you're probably more comfortable of thinking of speeds in terms of either kilometers per hour, km, over h, or miles per hour, mi, over h. In this problem, you will see that 1 meter per second is roughly 4 kilometers per hour or 2 miles per hour, which is handy to use when developing your physical intuition. More precisely, show that A. 1.0 meter per second equals 3.6 kilometers per hour and B. 1.0 meter per second equals 2.2 miles per hour. 34. American football is played on a 100-yard long field, excluding the end zones. How long is the field in meters? Assume that 1 meter equals 3.281 feet. 35. Soccer fields vary in size. A large soccer field is 115 meter long and 85.0 meter wide. What is its area in square feet? Assume that 1 meter equals 3.281 feet. 36. What is the height in meters of a person who is 6 feet 1.0 inch tall? 37. Mount Everest, at 29,028 feet, is the tallest mountain on Earth. What is its height in kilometers? Assume that 1 meter equals 3.281 feet. 38. The speed of sound is measured to be 342 meters per second on a certain day. What is this measurement in kilometers per hour? 39. Tectonic plates are large segments of Earth's crust that move slowly. Suppose one such plate has an average speed of 4.0 centimeters per year. A. What distance does it move in 1.0 second at this speed? B. What is its speed in kilometers per million years? 40. The average distance between Earth and the Sun is 1.5 multiplied by 10 to the power of 11 meter. A. Calculate the average speed of Earth in its orbit, assumed to be circular, in meters per second. B. What is this speed in miles per hour? 41. The density of nuclear matter is about 10 to the power of 18 kilogram per meter cubed. Given that 1 milliliter is equal in volume to centimeter cubed, what is the density of nuclear matter in megagrams per microliter, that is, mg over μl? 42. The density of aluminum is 2.7 gram per centimeter cubed. What is the density in kilograms per cubic meter? 43. A commonly used unit of mass in the English system is the pound mass, abbreviated lbm, where 1 pound m equals 0.454 kilogram. What is the density of water in pound mass per cubic foot? 44. A furlong is 220 yard. A fortnight is 2 weeks. Convert a speed of 1 furlong per fortnight to millimeters per second. 45. It takes 2 pi radians, rad, to get around a circle, which is the same as 360 degree. How many radians are in 1 degree? 46. Light travels a distance of about 3, multiplied by 10 to the power of 8 meter per second. A light minute is the distance light travels in 1 minute. If the Sun is 1.5, multiplied by 10 to the power of 11 meter from Earth, how far away is it in light minutes? 47. A light nanosecond is the distance light travels in 1 nanoseconds. Convert 1 foot to light nanoseconds. 48. An electron has a mass of 9.11, multiplied by 10 to the power of negative 31 kilogram. A proton has a mass of 1.67, multiplied by 10 to the power of negative 27 kilogram. What is the mass of a proton in electron masses? 49. A fluid ounce is about 30 milliliter. What is the volume of a 12 FL/OZ can of soda pop in cubic meters? 1.4. Dimensional analysis. 50. A student is trying to remember some formulas from geometry. In what follows, assume A is area, V is volume, and all other variables are lengths. Determine which formulas are dimensionally consistent. A. V equals pi r squared h. B. A equals 2 pi r squared plus 2 pi r h. C. V equals 0.5 bh. D. V equals pi d squared. E. V equals pi d cubed over 6. 51. Consider the physical quantities S, V, A, and T, with dimensions, open bracket, S, closed bracket, equals, L, open bracket, V, closed bracket, equals, LT to the power of negative 1, open bracket, A, closed bracket, equals, LT to the power of negative 2, and open bracket, T, closed bracket, equals, T. Determine whether each of the following equations is dimensionally consistent. A, V squared, equals, 2A, S. B, S, equals, VT squared, plus, 0.5A, T squared. C, V, equals, S, over T. D, A, equals, V, over T. 52. Consider the physical quantities M, S, V, A, and T, with dimensions, open bracket, M, closed bracket, equals, M, open bracket, S, closed bracket, equals, L, open bracket, V, closed bracket, equals, LT to the power of negative 1, open bracket, A, closed bracket, equals, LT to the power of negative 2, and open bracket, T, closed bracket, equals T. Assuming each of the following equations is dimensionally consistent, find the dimension of the quantity on the left-hand side of the equation. A, F, equals M, A. B, K, equals 0.5 M, V squared. C, P, equals M, versus D, W, equals M, A, S. E, L, equals M, VR. 53. Suppose quantity S is a length, and quantity T is a time. Suppose the quantities V and A are defined by V equals ds over dt, and A equals dV over dt. A. What is the dimension of versus? B. What is the dimension of the quantity A? What are the dimensions of? C. Integration of V dt. D. Integration of A dt, and E. dA over dt. 54. Suppose open bracket, V, closed bracket, equals L cubed, open bracket, rho, closed bracket, equals M, L to the power of -3, and open bracket, T, closed bracket, equals T. A. What is the dimension of integration of rho, dV? B. What is the dimension of dV over dt? C. What is the dimension of rho of dV over dt? 55. The arc length formula says the length S of arc subtended by angle theta in a circle of radius r is given by the equation S equals r theta. What are the dimensions of A, S, B, r, and C, theta? 1.5. Estimates and Fermi calculations. 56. Assuming the human body is made primarily of water, estimate the volume of a person. 57. Assuming the human body is primarily made of water, estimate the number of molecules in it. Note that water has a molecular mass of 18 gram per mole, and there are roughly 10 to the power of 24 atoms in a mole. 58. Estimate the mass of air in a classroom. 59. Estimate the number of molecules that make up Earth, assuming an average molecular mass of 30 gram per mole. Note there are on the order of 10 to the power of 24 objects per mole. 60. Estimate the surface area of a person. 61. Roughly how many solar systems would it take to tile the disk of the Milky Way? 62. A. Estimate the density of the moon. B. Estimate the diameter of the moon. C. Given that the moon subtends at an angle of about half a degree in the sky, estimate its distance from Earth. 63. The average density of the Sun is on the order 10 to the power of 3 kg per meter cubed. A. Estimate the diameter of the Sun. B. Given that the Sun subtends at an angle of about half a degree in the sky, estimate its distance from Earth. 64. Estimate the mass of a virus. 65. A floating point operation is a single arithmetic operation such as addition, subtraction, multiplication, or division. A. Estimate the maximum number of floating point operations a human being could possibly perform in a lifetime. B. How long would it take a supercomputer to perform that many floating point operations? 1.6. Significant figures. 66. Consider the equation 4000 over 400 equals 10.0. Assuming the number of significant figures in the answer is correct, what can you say about the number of significant figures in 4400? 67. Suppose your bathroom scale reads your mass as 65 kg with a 3% uncertainty. What is the uncertainty in your mass, in kilograms? 68. A good quality measuring tape can be off by 0.50 cm over a distance of 20 meter. What is its percent uncertainty? 69. An infant's pulse rate is measured to be 130, plus or minus, 5 beats per minute. What is the percent uncertainty in this measurement? 70. A. Suppose that a person has an average heart rate of 72.0 beats per minute. How many beats does he or she have in 2.0 years? B. In 2.000 years? C. In 2.000 years? 71. A can contains 375 ml of soda. How much is left after 308 ml is removed? 72. State how many significant figures are proper in the results of the following calculations. A. Open parenthesis, 106.7, multiplied by 98.2, closed parenthesis, divided by, open parenthesis, 46.210, closed parenthesis, multiplied by, open parenthesis, 1.01, closed parenthesis. B. Open parenthesis, 18.7, closed parenthesis, all squared. C. Open parenthesis, 1.60, multiplied by, 10 to the power of negative 19, closed parenthesis, multiplied by, open parenthesis, 3712, closed parenthesis. 73. A. How many significant figures are in the numbers 99 and 100? B. If the uncertainty in each number is 1, what is the percent uncertainty in each? C. Which is a more meaningful way to express the accuracy of these two numbers, significant figures or percent uncertainties? 74. A. If your speedometer has an uncertainty of 2.0 km per hour at a speed of 90 km per hour, what is the percent uncertainty? B. If it has the same percent uncertainty when it reads 60 km per hour, what is the range of speeds you could be going? 75. A. A person's blood pressure is measured to be 120, plus or minus, 2 mm Hg. What is its percent uncertainty? B. Assuming the same percent uncertainty, what is the uncertainty in a blood pressure measurement of 80 mm Hg? 76. A person measures his or her heart rate by counting the number of beats in 30 seconds. If 40, plus or minus, 1 beats are counted in 30.0, plus or minus, 0.5 seconds, what is the heart rate and its uncertainty in beats per minute? 77. What is the area of a circle 3.102 centimeter in diameter? 78. Determine the number of significant figures in the following measurements. A. 0.0009. B. 15,450.0. C. 6, multiplied by, 10 to the power of 3. D. 87.990, and E. 30.42. 79. Perform the following calculations and express your answer using the correct number of significant digits. A. A woman has 2 bags weighing 13.5 pounds and 1 bag with a weight of 10.2 pound. What is the total weight of the bags? B. The force F on an object is equal to its mass, m, multiplied by its acceleration. A. If a wagon with mass 55 kg accelerates at a rate of 0.0255 meter per second squared, what is the force on the wagon? The unit of force is called the Newton and it is expressed with the symbol N.